Hi, my name is Afrina. This is the truth table for an odd number counter. It counts up and down using odd number 1, 3, 5, 7, 9. Each number is shown in a binary form. The table shows how the output changes with each clock pulse. When counting up, it goes from 1 to 9. When counting down, it goes from 9 back to 1. Even numbers are skipped. This is the Canva map for the up counter. We use Canva map to simplify the Boolean expression. It helps us design the circuit more efficiently. The up counter increases the output in sequence. We fill the K map using the truth table's value. This is the Canva map for the down counter. The output decreases in a reverse order. After mapping, we simplify the expression.
Hello, I am Nurdini Izzati binti Norazmi and I will be explaining about the Boolean expressions used in this 4-bit up and down counter using JK flip-flops. Let's begin with the up counter. For Q1, it toggles on every clock pulse. For Q2, it toggles only when Q4 is low. For Q3, it toggles only when Q2 is high. And for Q4, it toggles when both Q2 and Q3 are high or if Q4 is already high. For a down counter, again, we have Q1, which toggles on every pulse. And for Q2, it toggles if any of Q2, Q3, or Q4 are high. For Q3, it toggles when Q2 is low and Q3 is high, or if Q4 is high. And finally, Q4, which toggles only when both Q2 and Q3 are low. For our timing diagram, the JK inputs we've set determine which flip-flops toggle when the clock ticks. For up counter mode, the counter steps through binary patterns of odd numbers. Q1 toggles every clock pulse. Q2 changes every 2 pulse, but only if Q4 is low. Q3 toggles when Q2 is high, so it changes less often, roughly every 4 cycles. Q4 toggles only when Q2 and Q3 are both high or when Q4 is already high. It changes the least, flipping at the end of a full sequence cycle. For our down counter mode, Q1 still toggles every clock pulse. But now Q2 toggles when any higher bit, Q2, Q3, or Q4 is high. This causes more frequent transitions early in the cycle. Q3 follows a more conditional rule, toggling when Q2 is low and Q3 is high, or when Q4 is high. Q4 flips only when Q2 and Q3 are both low.
My name is Nurihani Edina and this is our odd counter circuit successfully built in multisim using JK flip-flops. The first operates as an up counter while the second performs down counting. To ensure accurate and stable output, a pulse voltage source was used to generate clean clock signals which help the flip-flops produce the desired odd numbered sequence.